Hello and welcome to this special webinar on VLANs Demystified. I'm Debashish Roy, Senior Network Analyst at the Indian Cyber Civil Solutions. I welcome you all to this webinar and we'll discuss everything about virtual LANs and what are the importance of virtual LAN in today's networking that every IT professional needs to know. So I've already shared my screen and so let's start with the network segmentation, or you can say that if there is no VLAN, let's say there is no segment in the network and a switch is connected where you have all the pieces connected to the switches, hundreds of pieces connected to the switches. Now, as the number of PC grows, then the volume of broadcast traffic will also increase. And there will be very difficulty to log in to one PC from other PC. And also, there will be a security issue. So let's say there is a flat network. Now, what does this flat network means? Flat network simply means that there is one switch and all the PCs or servers are connected to that switch. So that is a one network only. So here you are seeing three switches, but let's say you are having only one switch. So we are not having any network segmentation and all are connected to the same resource. So in that case, what will happen that there will be too much broadcast traffic that will go on, and there will be also security issue in the sense that one PC will be able to access the other PC easily. If you haven't set up any access control list, anything like that, so definitely one will be able to access or hear other. So that would be a problem for your network. So we implement subnetting. We all know that subnetting is done by reducing broadcast. For reducing congestion in the network, you implement subnetting. And how do we implement subnetting? We create virtual LANs. So virtual LAN is totally virtual, means that it is logical, because in a switch network, in a switch fabric, it is a flat network, so everything is in a single broadcast domain. Means broadcast domain means a LAN. So in a switch, every PC is connected to the same LAN by default. So definitely we cannot say that physically we can do segmentation. No, we cannot. We have to connect all the pieces in the single location. Even if we use different switches, then also it is the same broadcast domain because it's a layer 2 device, and layer 2 device doesn't do network segmentation like the routers divide the collision domain and the broadcast domain, but the switch divides only the collision domain, means it's per port, it's one collision domain as we know, but it doesn't divide the broadcast domain. So that is why we'll go for segmenting our network by implementing subnetting. And to implement subnet, you want to create VLAN. It is totally virtual, means that again, it's a single broadcast domain, but actually you are logically dividing that, but physically it is a single broadcast domain. That is why it is virtual LAN. Now, you can see the design in this figure of the VLAN. There are multiple switches. There can be one switch, or it can span two multiple switches. And VLANs do not concentrate on one physical location, but it spreads across the geographical boundaries. It may be that there are some PCs connected to a switch in here in Kolkata and some switch in Bangalore or Hyderabad or any other location. There are multiple switches everywhere, and that is in the same VLAN. It definitely can happen because it is the subnet. If logically it is in the same subnet, then it is in the same VLAN. Now you can see that there are multiple switches, and in a company, say there are different divisions like accounting, say engineering, and some other departments. Now, it can be done this way, that in an HR department, in IT department, in accounting, you can have in marketing. There are different departments in a company. So in an enterprise, you can implement segmentation this way. But generally, it is not done that way. It is done according to the purpose. Say some pieces are for web server, some pieces are for file server, some pieces belong to the email server group. So according to that functioning, we create the VLANs in an enterprise. But in any way, you can segment your network this way, like these PCs belong to certain ports. We have the ports connected to the switches. Now, these ports are known as collision domains. Now, these PCs are connected to the switch port, and this will be considered a VLAN that would belong to one address space. Say this belongs to 10.0 address space. The marketing VLAN belongs to 20.0 address space. Accounting VLAN belongs to 30.0 address space. So this is like segmenting your network, and you are attaching the PCs to the ports of the switches. You are directly assigning the PCs to subnets. You are directly assigning PCs to VLANs, and it is manually done. It is manually configured. So we all know how to assign IP addresses to the PCs. So we assign IP address, and that IP address belongs to a particular VLAN. Now definitely you can use any subnet mask. It means that yes, you do not have to be classful always. You do not have to use only the default mask, but you can be classless. Let's say I want to use different subnet mask of any class, A, B, or C. Yes, you can do. But definitely the mask should be same for all VLANs. Like if I use 255 240.0.0, so it should be same for this and this. Otherwise, it will be difficult for router to distinguish the traffic. Because for inter-VLAN communication, you have this layer 3 device, that is router. For intra-VLAN communication, that is communication between, not between the VLANs, but inside the VLAN, you do not need any layer 3 device. It is performed by switch. But for inter-VLAN communication, you have something that is a layer 3 device, that is router. So the communication between the VLANs are done by layer 3 router. Now, if this PC is communicating with any other PC to any other VLAN, what would be the source and destination IP? So source IP definitely is this PC's IP, but what would be the destination IP? What would be the gateway? And what would be also the destination MAC address of this PC? If I say that this PC is communicating with this PC of the marketing VLAN, so will the source and destination IP and MAC will be of the marketing VLAN PC? No, it will not be, because your traffic will first go to the switch, and the switch will see that the network ID is different. It will perform an AND operation, and it will find out that the destination IP belongs to the other subnet, that is the other VLAN, and then it will straight send the packet to the router. That is its default gateway. So here the important part is its default gateway. So your source and destination IP will not change. It will be constant. The source will be of this PC, and destination is any other PC that you are sending. But the destination MAC address will be of this VLAN's gateway. In this case, say this is 10.0 VLAN, and you have set the gateway in the router as that, say 10.10 or anything. So that would be the destination of this PC, and that destination MAC would be that gateway's MAC address. Now, we have already discussed this collision domain and broadcast domain in terms of VLAN, but again, the router has per port different collision domains. Means it's each port collision domain means that where the packet is entering and exiting, that is the collision domain. That is the router and switch is a per port, and that is why the bandwidth is more in case of switch. But in case of hub, say there are 10 ports, but there is a single collision domain. So in case of hub, definitely there are too much collisions in a network. As we know that in any network, you will have some collisions. Definitely, it is not possible to create a network that is totally collision free. In any Ethernet segment, definitely there will be some collisions, but we can limit the collisions. Now here, in this case, router and switches, you have per port. These ports are the collision domain. Now, in case of broadcast domain, in case of router, you have the per port. So if this is the router, if you consider this not as a switch, but as a router, then you will have this network as one broadcast domain, and this network is another broadcast domain. So router actually segregates, it breaks the broadcast domain, and the broadcast domain that it creates, that will be individual VLANs. But in case of switch on hub, there is a single broadcast domain. Now let's come to the VLAN types. What are the types that we have? We have mainly two types of VLAN. One is static VLAN or port membership based VLAN, and one is dynamic VLAN. Although we do not create dynamic VLANs often nowadays. Static VLANs that we create mainly, that is statically assigning your PCs to the VLAN. Statically or manually you have to assign the PC to the ports of the switch, that is to the VLAN. And dynamic VLAN is created on only layer 3 switch. It is not available or it is not created on layer 2 switch. Using VLAN Management Policy Server or VMPS. That is an application that you have to install on the layer 3 switch, and it automatically gets the MAC addresses, MAC address of the PC, and it automatically puts the PC in some VLANs. So you do not need to manually or statically configure the PCs to any particular VLAN. That is the advantage. But generally, we do not use that. We use static VLAN only. Now, there are some VLAN ranges. How many VLANs can you create? Now, it depends on the VLAN identifier or the VLAN ID. So let's say there is VLAN 1, VLAN 2, VLAN 3. So this way, your ID goes. There is a VLAN number. Now, that VLAN identifier is 12-bit long. It is a 12-bit long number. So that is why you can get 2 to the power 12. That much VLAN. So VLAN 0 and 4095, that is reserved for the system use. And we cannot see or use these VLANs. And there is something known as VTP, VLAN trunking protocol, that is sharing the VLAN information between the switches or between multiple switches rather, but 0 and 4095 VLAN is not propagated via VTP. Now there is VLAN 1 that is known as the native VLAN. That is a special VLAN, a normal Cisco default VLAN. One can use this VLAN, but you cannot delete it. So it is by default there. And native VLAN cannot be deleted. And it is used to actually send some unencrypted traffic. And it is propagated via VTP. From VLAN 2 to 1001, that is the normal range for creating Ethernet VLANs. One can create, use, and delete these VLANs, and it is propagated via the VTP. From VLAN 1002 to 1005, these are again the default selections for Cisco defaults VLAN for FTDI and token ring networks. Although that is very old, but still it is reserved for these networks, and one cannot delete this VLAN range. It is also propagated via VTP. From 1006 to 1024, again it is reserved for system use only. And from 1025 to 4094, this is extended range of VLANs. Normally, we do not see in the simulators or in generally the routers, you do not have support for this extended VLANs always. And it is not supported in VT version 1 and 2, as we know that we have VT version 3 also. So there it is supported, but the VTP transparent mode should be there to configure extended range VLAN. So it is a special range of VLANs that definitely is not used so much. Now there are two links of the VLANs, that is access link and trunk link. What is an access link? It is a links connected to end devices, that is PCs and servers. And the VLAN data across the access link is not tagged, or it is not encrypted. It is unencrypted data. So if you are configuring access link, and if you capture the data in the access link, you will see that there will be no protocol information or tagged information in that access link, because data will not be tagged, and it is actually carrying a single VLAN information. But trunk link is a link between switches or between switch to router, and generally it carries tagged traffic of multiple VLANs. So if you have created 10 VLANs, it will carry the traffic of all the VLANs, and in a tagged manner means encrypted manner. And in trunk link, generally the data is carried in encrypted manner. But in case of native VLAN, if you configure native VLAN, that VLAN traffic also goes through trunk link, but that traffic is not tagged. Just I was telling you, native VLAN or VLAN 1 carries untagged or unencrypted VLAN data. Now, which type of traffic is carried through native VLAN by default? Control plane traffic means the routing information, the routing protocol. Say you have configured any routing protocol, say OSPF or EIGRP, anything, even the static routing. So that type of traffic is carried via native VLAN or administrative VLAN, that is there in default. You cannot create native VLAN. Native VLAN must be same on both switches. So if you are changing the native VLAN, you can change the native VLAN but on trunk links, but it should be same on all the switches. Otherwise, there will be native VLAN mismatch error. Switch port trunk native and VLAN ID, that you have to give the VLAN ID, is used to set any other VLAN as native VLAN. So this is the command through which you can set any other VLAN as a native VLAN, but it should be same on all the switches. Now there are two frame tagging types for the VLAN. So if you are encrypting the data in the VLAN, there would be two frame tagging types. One is very old, that is ISL, inter-switch link. That is Cisco's default method. And one is the .1q, or we say 802.1q, that is IEEE's methods. Now ISL is Cisco proprietary. So definitely it is not used in other vendors. If you are using only Cisco routers and switches, in that case, ISL will be there. But in case of .1q, it is vendor independent and it can be used in any environment. Say you are using a Cisco router and I'm using a Juniper router or switch. So in that case, definitely say Aruba switch. So in that case, definitely ISL will not be used. In that case, only the option is .1q, and ISL is very old. And nowadays in switch, in case of encapsulation, it is auto detect. Even if you want, you cannot configure the encapsulation type because there is no option now. You cannot select ISL. ISL is almost obsolete. Now only .1q is supported. So definitely it is automatically configured in the switch. Now there is the data type or the frame type. And there's a comparison between the VLAN data frame and we have the traditional Ethernet frame, that is Ethernet header. In the Ethernet header, as we know, you have the destination MAC address of 6 bytes, source MAC address of 6 bytes, length or type, that is 2 bytes. And then you have the data, that is from 46 to 1500 byte. Obviously, data means both MSS and MTU, both. And in case of MTU, it goes up to 1500 byte or maximum transmission unit. And you have 4 bytes of FCS or frame check sequence field to check the data integrity. Now, this VLAN information is actually inserted in this Ethernet data link layer frame. So there is destination address, source MAC address, and before the length or the type field, you have this VLAN tag of 4 bytes. So within that Ethernet frame, you encapsulate the VLAN data frame and it is tagged. In the VLAN tag, you have something known as TPID, that is Tag Protocol Identifier, and that is 2 bytes. PRI for priority, that is 3 bits. CFI, canonical format indicator, that is 1 bit, and VLAN ID. Now, tag protocol identifier, that is like whether it is an ISL or .1q encapsulation. Priority means that it is related to QS, quality of service. So if you want to prioritize any traffic, VLAN traffic, in that case, the 3 bits are reserved in that VLAN tag for priority field. CFI actually specifies if it is Ethernet or token ring VLAN. And TPID field also specifies that it is a VLAN data. It has a hex value, and it specifies that it is a VLAN encrypted data, either ISL or .1q. And VLAN ID is 12 bits long, that I've already told you. So this is actually, this information is encapsulated in the VLAN tag. Now that I've already told you, type is a 2 byte value called the tag protocol identifier, and the hexadecimal value I was telling you is 8100. It means if this TPID field has 8100 hex value, then it will specify that it is a VLAN data frame. Then user priority is a 3-bit value that supports level of service implementation, means the QS. CFI enables the token ring frames to be carried across the links, Ethernet links, token ring, or the FDDI. VLAN ID. So VLAN ID is a 12-bit VLAN identification number that supports up to 4096 VLAN IDs. So because it is 2 to the power 12. And next we'll discuss a very important topic also, that is a router on a stick. So in this case, you can see there are 2 switches, switch 1 and switch 2. And there is a trunk link between the switch 1 and 2, and also a link between the switch 1 and the router 1. Now the router 1 has this VLAN 10 and VLAN 20. These two are configured into switches. We can configure it on one switch also, but in this case, it is configured on 2 switches. Now the router on a stick means that router has only 1 gigabit Ethernet port. As you can see, we are only having 1 port, but it has to route traffic for multiple VLANs, for VLAN 10 and VLAN 20. So if we use the physical links, so we should have connected 2 links, one for VLAN 10 and other for the VLAN 20, but that is not possible because we are having only 1 Ethernet port, that is gigabit Ethernet port. So in that case, it is one link is supporting more than 1 VLANs. So it will be known as router on a stick. Means the router is standing, let's say it is imaginary, it is standing on one stick, and it is supporting multiple VLAN informations. And how do we create that? We create sub interfaces. We physically cannot add any other interface to the router. So we divide the physical interface, physical Ethernet port of the router into sub interfaces. So when we'll configure the VLAN, then we'll see in the packet tracer that we'll add the logical interfaces there, and sub interfaces means router on a stick. So router on stick is a feature which enables router to route traffic for multiple VLANs, that is more than one VLAN. So that is about the theory part for the basic VLAN configuration, and definitely we'll see the practical also of this VLAN. So let's now move to the practical part for this VLAN, where we will configure the VLANs, say on one switch here, that is between the two VLANs we'll create, and we will also take a router for inter-VLAN routing. So I'm taking a 2960 switch here. There is a Cisco Catalyst layer 2 switch and a router. So any router, you can take PT router or any other router. And for now, I am taking only two devices, that is two PCs. This PC will belong to, say, VLAN 10. And this will belong to VLAN 20. You connect it with straight cable only with fast Ethernet port 2, say fast 0x1, and here to say any port, in this case 0x2. And you trunk F0x3 to this router Ethernet port. First, you have to create the VLAN database on the switch, because we do not have any VLAN configured on the switch. Just click on the switch, go to CLI, enable, and if I give show VLAN brief, you can see that there are no VLANs, but only VLAN 1, that is a native VLAN. All the ports by default are the member of the native VLAN, and you have this 1002 to 1005 FDDI2 token ring. These are the default VLANs that are active, but we do not have any other VLANs created on the switch. So we need to first create VLANs on the switch. So go to config mode and say create VLAN 10, name, say you give a name, say VCNA, exit, and again VLAN 20, name, say CCNP. So we have created the VLANs, VLAN 10 and VLAN 20, but we haven't assigned the VLANs to any other interface. So next we'll assign the VLANs to the interfaces. See? Now go to interface 0x1. You have to first configure it as an access port, switch port, mode, access, and you assign VLAN 10, switch port, access, VLAN 10. So we say 0x2, switch port mode access, switch port access, VLAN 20. So we cannot use VLAN 1, but we can use from VLAN 2 here. I am creating VLAN 10 and 20, and I am assigning the VLAN to the ports. And now you have to next trunk the port, that is F0x3, that is to the router. So go to the interface F0x3 and you give this command, switch port mode trunk, and the encapsulation, it's automatically .12 and it's automatically there. You do not need to configure, or if you configure, it will not take because it's auto detected. Go back to the config mode, and now let's go to the native VLAN, that is interface VLAN 1. Now you have to give an IP address to the switch because it needs to communicate with the router. So just give no shut command And now you give the IP address. You give the IP address, say IP address 192.168.10.1. And for now, I'm giving default mask, but you can give any other mask. And 10.1 is a switches IP. Now, in router, there is definitely an IP of the router's interface, gigabit port or fast Ethernet port. There is an IP. So let's assume that router port's IP is 10.10. So switch's default gateway would be the router's IP address of the Ethernet port. So you will give the command IP default gateway 10.10. So we have shrunk the port. We have assigned the ports to the VLAN. We have gone to VLAN 1, given the IP address of the switch, and we have given the default gateway. So these things need to be done in the switch, and give Control Z and come back to the privilege mode and give the command again, show VLAN brief. As you can see, now there is VLAN 10 and VLAN 20. 10 is CCNA, 20 is CCNP, and is active. VLAN 10 for F0 by 1, VLAN 20 for F0 by 2. So that is the VLAN database that we have in the switch. But still, the VLANs cannot communicate. If the pieces are belonging to different VLANs, they cannot communicate because we haven't created any sub-interface or router on a stick on the router. So let's go to the router and create the sub-interface. So here I'm going to the router. Interface, here we have Ethernet port, just give no short. And here, do not give any IP address. Do not give any IP address. So let me see if the port is coming up. Yes. And here you create the sub interfaces. Interface F0 by 0.1. Now this is the router on a stick. Means we are creating sub interfaces on the router. This is the first sub interface. It's already up because it's a logical interface, and physical interface is already no shut, so it will be automatically up. And there you give the IP address of the router itself. So here you specify encapsulation first. What type of encapsulation it takes? It takes .1q. So you give .1q and the subinterface number 1, IP address, let's say 192.168.10.10, and the subnet mask. So this would be your router's IP, and the switch will send the traffic to this IP. Switch will communicate with the router, and router to the switch with this IP. Now we have to create the VLANs gateways. The gateway for the VLAN 10 and the gateway for the VLAN 20. Now in this case, create the interface F0 by 0.10, because this sub-interface number and the VLAN number in the switch must match. If you say do not do that, if you create any other sub-interface, say F0 by 0.2 or 3 or anything, no, it will not be able to communicate. So this number is very important. It should match. Give the encapsulation .1q 10, IP address. Let's say the gateway would be 20.10. It can be anything. That will be the gateway for the PCs in the VLAN 10. And then interface F0 by 0.20 for VLAN 20. Encapsulation also should match .1q20. And then the IP address say the IP address, the default gateway would be 30.10. So the PCs in the VLAN 20 will get the default gateway, that is 30.10, and the PC in the VLAN 10 will have the default gateway, that is 20.10, and the IP address for the router, that is 10.10. And that is it for the router communication. Now the configuration is complete for both switch and the router. And now just go to the PCs. This belongs to the VLAN 10. So go to desktop, IP configuration, and give any IP in the 20 network, 192.168, say 20.50, and the default gateway would be 20.10. So in this case, 30.50, it can be 30. Anything, and the gateway 30.10. So if you are giving this IP address this way, now it should communicate. Now you ping that, go to command prompt, ping to 30.50. So first request will be timed out for R, and then it should ping, and it's pinging, as you can see. And if you go to the simulation mode, and if you click on this add simple PDU, and you click to VLAN 10 to VLAN 20, and you just play that packet. So you can see that the packet is going to the switch. Then the switch forwards the packet all the way up to the router interface. And then again, the packet is coming to the switch. And then this here. So this ping packet is actually, it is the communication is happening through the router. And you can see the header part as well, that its source is VLAN 10, destination is VLAN 20. You can see the in layers. In layers means where packet is entering, and out means where packet is leaving the interface. So in layer 2, you can see the source, destination, MAC, everything here. And you can see the inbound data. You can see the Ethernet frame. And this is MP only, because we are not having here VTP, because there is no such two different switches, only one switch. So definitely we do not have any VTP. So it is only the IP frame you are having. So this is the data, this is a data packet that you can see. So this way you can configure the VLAN on the switches, and this is on the layer 2 switch. But the newer thing is the layer 3 switch, and that also we should see, because the VLANs are not only a matter of layer 2 switch, but it is a matter of layer 3 switch also. So what we can do, we can go to again switches, and these two are the layer 3 switches that works in the network layer. So you take a switch and again take two PCs, connect it to the gigabit ports, and if you click on the multi-layer switch, and if you go to CLI, it will say device must be powered on. So what you need to do, you need to go to the physical, and you need to drag this AC power supply, you need to connect it to any module. And then if you go to CLI, it will boot. So first you need to create the VLAN database as we did in the layer 2 switch, but here we'll configure switch virtual interface, or SVIs. So let's first create the VLAN database. VLAN 20. It interface. This one is gigabit 1 by 0 by 1 here. Switch port mode access and switch port access VLAN 10. Interface gigabit 1 by 0 by 2 and switch port access VLAN 20. So this is same, but here you do not need any router because this is a multi-layer or the layer 3 switch. So it will act as a router. So it acts as both router and switch. By default it is switch, but it can be a router. The router capability should be there. So you do not need to create any router on a stick. You do not need to create any sub interface. So what you need to do, go to config mode and you create SVI, switch virtual interface. That is a logical interface in the name of the VLANs. Let's say interface VLAN 10. It's a logical interface. It is a SVI. That was not there in the layer 2. In layer 2 switch, you cannot create that. And it's already up because it's a logical interface. And here you just give the gateway of the VLAN 10. It is very easy and the configuration is very easy in a layer 3 switch. So you just give the gateway. Let's say gateway is same 20.10 that was there. You do not need to specify any encapsulation, nothing. It is only a SVI interface VLAN 20. Give the IP address, say 30.10. So we have created the VLAN database. We have assigned the interface to the respective VLANs, and also we have added SVIs, and we have added the gateways for the VLANs. So nothing else we need to do. You just give the IP address to the PCs. This will belong to the VLAN 10. Okay, it is not allowing because already VLAN 10 is there. So it is not taking the name. Anyway, we can add the IP address here. $20.100 and the gateway is 20.10. Say it's 30.100. Now, if I want to communicate, you just ping from this PC to that PC in the other VLAN, and let's see what happens. One packet should be timed out and then it should ping, but will it ping? But it's not pinging. Again, you are getting RTOs, request timeout. Why? Because I've told you that layer 3 switch, it is by default a switch. It is not a router. So the router capability is by default not enabled. It is disabled. Or the routing simply is disabled on a layer 3 switch. So you have to enable that. Go to config mode and give this command IP routing. And now if you give this, and if you give this command in the switch, show IP route, you can see the routing table, the route table in the switch as well. You can see that the VLAN 20 and 30 is connected to 10 and 20 respectively. So we can see the routing table. So now the routing is enabled. And now if you ping, it should work. Yes, it's being. So definitely it is now acting as a router. So by default, this routing capability is not there in a layer 3 or in a multi-layer switch. So you have to enable the IP routing. In any router also, if you want to disable the IP routing, you can do it by giving no IP routing command in the config mode. So in that case, the routing capability will be disabled and you will not be able to view any route table. So this is the layer 3 VLAN, and we can create voice VLAN also, that is related to the VoIP devices, voice over internet protocol supported devices like Cisco IP phone, for instance. And if you want to make the Cisco IP phone a member of any particular VLAN, then you have to create the voice VLAN. But the voice VLAN is not there till now in the CCNA or CCNB. The configuration, we do not have that here in the Cisco blueprint because it is in the Cisco collaboration, or previously what was known as Cisco voice. Now it is known as the Cisco collaboration. So here we have the Cisco IP phone and all other Cisco voice related devices. So there you will configure the IP phone and you make a member of the VLAN. But yes, the voice VLAN is there. That is only for devices supporting VoIP, voice over internet protocol traffic. So in the access link, you just create that VLAN and you add that device, that will be voice VLAN. So VLAN still, in the days of automation, we know that the VTP is not so relevant maybe nowadays because the VLAN trunking, all these things are now being done gradually by automating the task, the automation by scripting. But VTP is there, and I think it will be there to stay for some time more. And VLANs play an integrated part in your network to minimize the congestion and the broadcast traffic. For broadcast controlling, for network segmentation in the enterprise network, we can do network segmentation differently in the BGP protocol in the ISP level. That is a different thing. But in case of the enterprise networking segmenting network, VLANs play a very major role. And in case of CCNA and CCNP also, in the curriculum, as we see that it has a lot of things related to VLAN. And in the CCNP level also, you will capture the packets in the VTP or VLANs. And that I already discussed the frame format of the VTP, the fields, the TPID, CFI. This is a very important part when you will capture the packets in the CCNP level, the trace files, that is very important. So I have discussed all the important points of the VLANs here in this webinar, and this is a very important part for your Cisco studies. And in case of the NRC and the ENCORE, both paper we have the VLAN concept there, mainly in the ENCORE, the enterprise core, that is paper, the mandatory paper for CCNP, and also in the CCNA, the associate level, we have still the VLAN as a major topic for the layer 2 switching. So in the switching part, VLANs play a very important role. So that is it for VLAN for now. And I hope that you have got immense knowledge on VLAN and also the switching technologies here. And it will be very helpful for your career in the Cisco networking as you progress. And VLANs are here and it will be there also to stay. It will be there. So definitely it will create definitely a major impact in the networking role. So I again welcome you all, and I definitely wish you all the best for your Cisco career. And that is it for VLAN. Again, we will discuss with some more topics on some trending technologies like other VLANs or any other burning topic in future. And thanks for joining this webinar. And that is it for VLAN for now. I will come back with some new topics in future. Till now, bye.